Before we start, let's see what do you think about network, right? What is network? Interconnections of computers. Okay. Why do we need to connect the devices or computers, right? Why do we need to connect the devices, Fabio? We can share the information. Very good. That's is very good. Good. So we have completed the definition of our network. So a network is a connected collection of connected devices or interconnection of the devices or computers so that they can share the information. Now these days when we say computers, it means that any device, any end device like smartphone or tablet, right? So all of them, when we say computer, so computer term has become generic now. It is rather than being specific, that has become generic, right? So anything which is running some applications and which communicates on the network, they are computers, okay? So, or you can say host, or you can say end devices. So these will be the terms for that. So we basically connect the devices in network. Why? Because we want to share information, right? Or data, right? Raw form of information, right? So this is whole thing becomes data communication, right? We call it data communication. Right? So sometimes you will see that data communication and network, right? So we connect the devices within network so that they can communicate data, right? So that makes data communication and network. Now, if I will say that what type of information we share on the network, what would you tell me? Any example? You use that network every day. So what do you do on your network? What do you share? Any specific pictures, documents, right? Anything else? So if we see that, how many forms of data we share? We said that we share the data, right? How many forms of data we share on network? Or we can say internetwork, right? Text. You said document, right? Text. Image. Audio. Video, isn't it? Yeah. So we have 4 forms of data. We don't have any other form of data which we basically share on internetwork, right? Now, normally we use terms client and server, right? What do we mean by these terms? On network, what is client and what is server?
Client is a system where we access text, image, and audio and video from the server, or we access from each other.
Okay, yeah, go on.
End user device.
End user device. Server is not end device. Yeah, let me tell you. So our internet is client and server based, right? Client sends request right? And server sends response. So we have two types of devices, right? Or two types of applications. We can say it's a client application or a server application. Client application sends the request and server application sends the response. And if we see that, that's what we do all day long, right? Very good example of that is web browser and web server. What do you do on web browser? You send the request to get a web page, isn't it? And web server will send you the web page, isn't it? If you would have used a file service, what is file service? You have a client application which you will need to request a file from file server, isn't it? So that sends a request to give me a file, right? And server sends a response and it gives him the file which he needs. Same thing is email. You have email server, you open Outlook, which is an email client, isn't it? And that email client, which is Outlook, that connects you with the server, email server. And you get, and it sends a request and it sends email, all the emails which are basically saved in your inbox on server, right? That comes to your email client, isn't it? So that is the main idea. If you see that, internet will be full of client and server applications. Now we know that what is client and what is server. You understand? So if we will see, that we have got come on. It's our internet, and on internet we have got different types of server, and there are different people who would basically want to request different things from the servers, right? So they connect with the server and they get the information from the servers, right? So this is what is happening on your network. Now, as a network infrastructure, what it does, network infrastructure facilitates or provides services to these client and server applications to send their request and response to each other. So that is happening. That is what we will be as a network engineer facilitating. We need to make sure that these applications, client and server application, can send and receive data. Now, obviously, this client and server, they will not be sitting next to each other, right? They are very far from each other. So the whole thing they will be relying on, these client and server, they will be relying on the internet, on the network, right? If the network has not connected them, if the information cannot be reaching to the server from the client to server, then server will not be able to respond, right? And vice versa. So don't you think that this network connectivity is very important, isn't it? And the information which is going from this machine, let's suppose, and if it sends to this machine, it should be going from here straight here. It should not be ending up to any other machine, right? So there may be millions of machines, millions of servers, but that information should straight away go to that server which this client is sending request to. If it is going to somewhere else, it is not good. Yeah. So there should be a proper routing mechanism, right, between these two. So this information will be routed, and this will be totally relying on routing right? That if the routing is not correctly configured, then this information can never reach there. So you can see that, the critical part of an important part of your routing, right? Yes.
So basically,
Job of the person who is configuring the server, right? Server job. For example, you have a shop in here, right? So your job is to open a shop where people come and buy. You understand? Right? Yeah. So you open a shop, rest of the people are client. But how would they come to you? You need to have a proper address, isn't it? So that you can tell people here is my shop, right? But address is not enough. If you give me address and that is ending up in a mountain where no road is going, would I be reached there? Right? Do you understand? I need to have a proper infrastructure so that I can reach there and I can buy things from you, isn't it? Now the server, you install a server. So that is a server, that is a system administrator who install the services. But the network engineer's job is to provide the connectivity. Okay, so that is a different job. That is the server person's different, network person is different. Understand? Okay. So you will understand this thing when we will be going. So at the moment, what is our task? That all the information between these devices, they should be reaching there correctly, right? And to correct the device and to correct the application. Okay. Any question?
I would like to know how they will connect me to the network. Obviously, they're not gonna put every host IP.
Okay, so this is our main objective, that we would want that these devices should be able to reach each other and these applications can talk to each other. Okay, so first of all, what they needed to do and what they have done, that when someone will want to send information, when it's like some device want to send information, what step it needs to go through, okay, before sending the information. Let me ask you a simple question. When you send a letter to someone, what steps you perform? Just think about it. What do you do from very scratch? What do you do? Write a letter. Very good. You have to write a letter, right? Okay, then?
you need to know the address of the
Okay,
receiver.
yeah.
Then we have to post it.
But how we post it?
Service.
What do you do? I need steps. I need a clear steps. Okay, 1, 2, 3, 4, 5. These are the steps which you will do from very beginning. And then I will tell you how they relate to this thing. Put it in the envelope. Very good. Address. What kind of address you will put? The receiver's address, right? Would you put a sender's address as well? Right? Would you put a name or just put an address? Full address, no name? Sender's name and address, and receiver's name and address, right? And then you just close the envelope and put the stamp. And then what will you do? In the post box. Then you physically go in there and post in the post box, right? Now let me tell you that the steps which are performed by your device when it will be sending any request, these are same, right? Only the names are different. Okay, there are two networking models which basically define these processes. One is called OSI model and one is TCP IP model. Have you heard of them? Right? So according to OSI model, how many steps we have in OSI models?
7 layers.
So it means 7 steps, right? Now you must have heard about these steps, but today you will exactly know what are this all about. And all of your networking is based on these models, OSI model and TCP IP model, okay? So TCP IP model is a process with which any device will send its request, or any server will send its response. So it will go through these steps, right? And send. So we have got first layer or first step, application layer. Second is presentation layer. Third is session layer. Then we have got transport, network, data link, and physical layer. So let's suppose this is client machine. Client machines is any machine where client application resides. For example, we will talk about, because we will use we use this application often, which is web browser, right? So you open a web browser on this, yeah, and you basically write www. anything, yeah, and then you press enter, right? Now what you want to send, you want to send a data. So this application, this web browser, this will generate a data, right? And this data needs to be going to this server, right? Like when you write a letter, right? This is what this application has done. It has written something, and it is a message which it wants to send it to the other side of the server, right? Then it comes these 7 steps. So it is this is not going to go out from this machine until these 7 steps will be performed. Okay? So in the first request, this is application layer. So application layer provides services directly to the application, right? So first thing comes application. So it will basically look at the data which it wants to send. It is like application. What kind of application is this? It's a web request. So he is going to be putting all the information about this application, about application header. Application header, right? So that is kind of like it creates a request, specific request, because there are other applications as well, right? So you will see there are many application layer protocols which you use for different kind of messaging. For example, you use HTTP. You will come across with that. HTTP. Have you heard of HTTP? What is HTTP? Transfer protocol, right? So this is HTTP. What is it used for?
Transfer the text.
Hypertext transfer protocol. It sends hypertext, right? It transfer. It tells itself. It transfers hypertext, and that protocol is used whenever two applications want to transfer hypertext to each other. They will use hypertext transfer protocol, right? When two applications want to transfer file to each other, they will use file transfer protocol. When they will want to transfer mail, they will use simple mail transfer protocol, right? Yeah. So there are many other protocols like Telnet, DHCP, DNS, right? Many application layer protocols. They have different purposes. What you want to transfer, right? And that's what they will do. So that is the process in network, right? You might have heard of these things, but you didn't know the meaning of that, right? But this is what we will see that. So this is what you will be learning, that what each protocol will, what is the purpose of that? Okay, this is the protocol, this is application layer protocol. What kind of information it is sending, it is used to send. Like for example, HTTP, now you know that. You can say that these are when the two applications want to transfer hypertext to each other, because all the websites are written in hypertext, isn't it? It's like HTML, hypertext markup language, isn't it? So they will be sending each other hypertext. Okay, so this application would want to, other application want application to understand this request. You understand? Now this is basically application to application. So you put application header in it, and then this will go to presentation layer. So this presentation layer, it will put an extra header. So you have application header already, and put a presentation header. What presentation layer will do? For example, you said that you wrote a letter, isn't it? When you were sending a letter, you wrote a letter. But let's suppose you wrote a letter, which language you know other than English, Laksh? Tamil. If you write a letter in Tamil to Wahid, would he understand? He's not going to understand that, right? So if you would want him to understand, would you put an extra information which he will, because if you will write a letter in Tamil, he will not even know that which language it is. So if he will need to have a translator, he will not be able to call some translator because he doesn't know, right? So would you put like, this is Tamil, this is written in Tamil, right? Yeah. Okay. So that kind of information you will be adding in there, isn't it? So that is what presentation layer do. Presentation layer translate the information, whatever data you are sending. It could be of any format, but what kind of format is it? What format? For example, sometimes you compress information so that it will be efficiently transferred on the network, right? Video is a very big file, right? Sometimes you compress it, you use compressors. You compress it before you send it, right? But when you compressed it, what kind of software, what kind of tool you have used to compress it, right? You need to tell the destination device that I have compressed it, and if you want to decompress it, you need to use something, isn't it? Sometimes you encrypt the information for the security reason, right? You do encryption so that all the application which will, you know encryption, right? Encryption means like changing the information so that nobody will be able to read it in the middle, right? So if you are encrypting it, how did you encrypt it? If it will reaches to other side, it needs to decrypt it, right? So that information you need to tell. Okay. Have you heard about ASCII code or ABCD code or binary codes? Have you heard of them?
Yeah, those codes we used to use encryption.
No. They're not used in encryption. They basically translate your, your text into binary. When you press A, B, C, D, E, F, right? How your computer knows about that, whether you pressed A or B or C or D or 1, 2, 3 or symbol, how does it know? Because computer knows only about binary, right? So when you press something, it generates a binary number, right? That goes to your computer. So these are called binary codes. There are two types of codes, for example, is ABCD, right? And ASCII. There are two types of code. Now, if you have written something and you're sending something to other device, and if it is written in AppSedic, and you need to tell other side that I'm using AppSedic for this binary code, isn't it? So that is also information. So this kind of things you will be putting it in a presentation layer header. You understand? So that other device will see that presentation header, and he will know what kind of format is it. So other side operating system will understand that what type of format is it, so that it can translate it and give it to application layer. Right? You understand? So that is presentation header. Then it will go to next step, and that will be your data application header, presentation header, and then you have session layer header. What is session layer header? Now, when you send something, for example, whenever you want to talk to someone, right? Don't you take permission? Can I talk to you for a minute, right? And then you want to, like, if he gives you permission, then you start talking, isn't it? So this application wants to communicate with other application. This application need a permission, isn't it? Yeah, to open a session. Okay, so this session layer, what it will do, it will request other application to create a session so that we can start a data transfer. Okay, so that session layer header, what session layer do? Session layer creates the session with other application. It maintains the session. If session is created, then it maintains the session. So all the data which you have sent in during the session, it basically maintains. And then once the data transfer completes, it terminates the session. Do you get it? The next time you need to create another session. So session layer will have the information about the session, right? And it can create the session with another application. Sometimes, you give a password and username, right? So that is a session layer. So to create the session, maybe other application will ask you to give you session information, username and password. Do you get it? Right? Now, what we have put in there, application header, presentation header, and session layer header. In TCP/IP model, right, all of these things happen. In TCP/IP model, we have got these layers. So we don't have, if you see that this is a typical model of TCP/IP, this is, you can say that this is a practical version of that. So in this, if you see that we have got application layer, this one, we have got transport layer, we have got internet layer and link layer. It is not like it does not have presentation and session layer. The only difference is that it has incorporated or combined or merged presentation and session layer within application layer. Right? So TCP/IP model says that these all three things, which is application, presentation, and session processes, they are related to application. They have nothing to do with network, right? For example, if you see about letter, you wrote a letter, what language you have written in, right? Whether other person is ready to read your letter or not, this has nothing to do with your postal service, isn't it? Postal service doesn't matter. It doesn't matter for postal service that whether you are sending a letter in English or Arabic or Persian, right? It doesn't need to know, right? This is what. So in this one, what format the data is, right? Whether you are sending a GIF or JPEG image, or you are sending a BMP image, or you are using MP2 or MP3 or MP4, what kind of files you are sending, right? You are writing in AppSedic or you are writing in OSI. It has nothing to do with the network. Network job is to whatever you send, whether it is good or bad, it will be received by other side. That is what network do, right? So these three things, these three app layers which are in OSI model, these three layers, application, presentation, and session layer, right? They are in one application, one layer, which is application layer. So that is a difference which you need to know between OSI and TCP/IP. Okay, so these three layers, but still application layer of TCP/IP model perform these processes. Okay, but we don't look at them separately in TCP/IP model. Okay. Now, if you see that this is the whole message, when you have included all these three headers in it, right? This has become a message. What is it? This has become a message. Now, this message need to be delivered from this application to another application, right? Now, next thing comes a transport layer. What transport layer does? Transport layer is a very important layer because it sits between the network and the application. So what is the job of transport layer? To prepare this message or data to send it on the network, right? Before it goes on the network, it will send it. Now, maybe the message is too long, right? So if it will be sending a too long message, it will take the whole bandwidth, isn't it? Yeah. And the problem is this is one of the problem, right? If you're sending a big video file, if it will be sent all in one go, it will take your whole bandwidth. And if we are all sharing same internet connection, right? So we will have to wait for other person whether it completes its whole transfer and then we will be able to use it, isn't it? But that's not what happens in reality. Okay, we all share the same internet connection, but we don't see anything like we have to wait like for 1 hour, right, to get access to the internet, right? But how? It is because of transport layer. What transport layer does? Transport layer divides this message into small pieces if they are bigger than some certain amount. We will talk about that. Okay. What will be the size of each piece? What should be the size of each piece? So this message, if this message is longer than some certain amount, then it will basically divide it into small pieces. Okay? Yeah? And each piece, it will be including a transport layer header. Sorry. Each one. So what we did, the whole message we have divided into small pieces, and each piece will be having a transport header on it. And we call each piece of this is segment. What we call it? Segment. So when you have divided this whole message into small chunks, and you put the header on it, that will be transport layer header. The next step will be the network layer. Then each piece will be going to the network layer. And what network layer will do? It will put a network layer header, right? Right? And this will be along with network layer header and transport layer header, it will become packet. What is it? Packet. And what it will be putting in transport layer header, we will be going into the details of that, what will be in transport layer header, what will be in network layer header. Very important information. It will be having the IP address of the both machines. In transport layer header, we will be having, now what I asked you, what do you put on the letter? You said address. I said like only address, right? I said name and address, right? Now you look at that, these two layers, transport layer, what it will be doing, it will be putting the port number. Every application, every network application which communicates on the network, it must have a port number. Okay, we will come into the details of we'll go into the details of that, right? Every application, when you open a web browser, it will have a port number. Your web server, it has a port number. Okay, without the port number, you can't send anything. Okay, so what will be the port number of that application? That is kind of a name. Like in postal service, we put the name of sender and receiver, isn't it? So source port number and destination port number. What these port numbers will do, when the message will be going to the next machine, it will be telling him that which application this message is coming for. You understand? Because you may be running like 5 applications. Like in your house, if you receive a letter, you may be leaving 5 people in there. So letter is there, but if there is no name on it, how can you know that whose letter is this, right? So the port number will tell that which application message is it, right? So that is the port number. So in segment, in tree transport layer header, what you are putting? Source port number and destination port number. When it comes to the network layer, what it will put in a network layer header? It will put source IP address and destination IP address. You got it? So what IP address will be? Like your address. So this TCP, TCP header, or TCP header, I'm saying that, transport layer header and network layer header combined makes your full name and address, isn't it? Yeah? It's the same thing like that. Okay? Now, this packet is ready. This is your letter. Right? It is IP packet is equal to your letter which you need to post, isn't it? So what you said physically I will go to letterbox, I will go to post office and I need to deliver it, right? Now this letter needs to be delivered physically somewhere, right? So that's where your data link layer and physical layer comes in. So data link layer and physical layer will help the device to physically transmit the data to this. So what it will do, when it will come to the data link layer, it will include this. So you have a transport layer header, you have a network layer header, right? And then data link layer will put its own header, data link layer header, and it will also put data link layer trailer. Okay? So whatever you packet have, right, it will have a data link layer header, and within data link layer header, it will be putting the physical addresses. Which device is going to be physically transmitting this and which device is going to be physically receiving this. That is your frame. Okay? So once you added data link layer header and data link layer trailer, it has become a frame. And once it will be a frame, so this needs to be physically transmitted. So if you see these are 2 devices directly connected to each other, let's suppose, right, they are directly connected to each other. Let's suppose, right? Yeah. So this is your network interface card, isn't it? Yeah. And this is your network interface card. You just connected these 2 devices together, let's suppose, right? To make it very simple at the moment, just to understand this, the process, right? Yeah. So then this physical layer, what it will do, it will convert this whole frame into binary, into zeros and ones, okay? So this will become 0, 0, 0, 1, 1, 1, 0, 0, 0, right? So this will be a whole thing will be converted into binary by your physical layer. And then these zeros and ones needs to go out of this wire in form of current or in form of signal. Yeah. So what physical layer will do, it will convert this whole frame into binary, and these binaries will be going into signal form. Now this could be your physical media, and it will send it to the physical media. What could be your physical media? It could be your wireless. Yeah, maybe these 2 devices are not connected through wire. These are connected through wireless. So if it is wireless card, then it will be converting it into radio waves, right? And if it is connected through a copper wire, then it will be converted into electric signal. If they are connected through fiber optics, then it will be converting it to light signal. But it's up to you. You know, you want to go to a post office by walk or by bicycle or by car, right? But at the end of the day, what is the purpose? To go in there and post the letter, isn't it? Yeah. So physically, these are the media, but there is no difference. So whatever media you are using, whether you are using wireless or light or, you know, electrical, all 6 steps which I have told you from application layer to data link layer, they will remain same. Okay? So whichever device will be sending, so they will be, so that zeros and ones will be going in form of electric current, right? It goes here and then it will be ending up in here first, right? The physical layer will receive all these electrical signals and convert it into frame. So that will be frame, right? And what if this frame has come for this device, what it will do? It will remove this header and trailer, and then it will deliver it to network layer. The network layer will look at the source IP address and destination IP address. If that is the destination IP address is the IP address of the device, right? It will further open it. Okay? It will remove this network layer, right? And it will give it to the transport layer. Yeah? And then transport layer will look at the port number, destination port number, which application it has come for, right? And whichever application it has come for, it deliver it to the application. And then application will see that whether it needs to open the session or not, right? It will open the session. If it will open the session, then it will give it to presentation layer. And presentation layer will translate this to the application layer, and it will tell him what kind of data or format or this was. An application layer deliver it to the user or user application, which is web service, isn't it? So it will deliver it to the web service. And that information, and the one side, this side is called data encapsulation. And this side is called de-encapsulation or decapsulation. Right? Means like when the latter will be reached on the other side, what the other side will do? It will rip it off, open it, and read it, isn't it? So that is the same steps which will be performed. So any application, so if you will be looking at the network communication or data communication, you will be looking in the perspective of OSI or TCP IP model. If you will do that, you will understand everything, what is happening. So you will not be detracked. That is why it is called OSI reference model. It will help you to understand, design a network, configure, right, and troubleshoot your network. You will understand that which side, which way, where is the problem, right? You get it? Any question? No. Very good thing which Wahid said. And this is what I say to my students. If you understand these two things, you will never have a problem with mainly OSI model, right? Subnetting is a math you can learn, you can practice, you can learn easily. But this process, you have to make a habit. Whatever you understand in the perspective of OSI. Ask yourself a question: which layer I'm talking about? When you are talking about routing, which layer you are talking about? You are talking about layer 3, which is network layer from the bottom, right? Yeah. If you are talking about switching, what layer you are talking about? You're talking about layer 2, which is data link layer. So routing and switching is all about network layer and data link layer. You understand? So that is what you will see, that when we will be sending a message, I will tell you which layer it is, and you will understand. It's like, oh yes, this is the thing. And it doesn't matter then what, if you build something or your networking knowledge on top of this, you will be going in the right direction. Understand? That I will be talking about this again and again, and you will understand. And today we will be focusing on this, right, most of the time. Okay.